Welcome to Safeguarding the Flow of Quality, where we dig into the science, the strategy, and the behind-the-scenes decision-making that keeps dairy and liquid food products safe from start to finish. I'm your host, Mara, and today we're discussing how bacteria attach to surfaces, why certain materials create bigger risks than others, and how proactive biofilm surveillance turns all of that into real-world decisions for quality assurance teams. Biofilms are stubborn. They're costly, and they're surprisingly good at hiding in all the wrong places. But here's the twist. Biofilms aren't random. They follow predictable patterns. And when you understand those patterns, contamination control starts to look a whole lot more manageable. Let's start with the big question. What exactly is Proactive Biofilm Surveillance, or PBS? At its core, PBS is a shift from reacting to contamination toward anticipating it. Instead of waiting for high APC trends or an unexpected coliform spike, PBS helps you look ahead and identify where biofilms are most likely to form based on surface type, environmental conditions, and microbial behavior. In other words, it's a smarter way to focus your monitoring efforts. And for processors juggling tanks, totes, drums, lines, and constant product movement, that kind of clarity is pure gold. Let's jump into the science behind biofilm attachment. Biofilm formation always starts with bacteria trying to attach to a surface. Picture a microscopic tug-of-war. On one side, you've got forces repelling the bacteria, like electrostatic charge, and on the other, you've got things like hydrophobic interactions or conditioning films pulling them in. Here's where dairy and liquid foods get interesting. Most surfaces and most bacteria are negatively charged. That should cause repulsion. But the moment divalent cations like calcium or magnesium enter the picture, the game changes. They act like little bridges, neutralizing charges and allowing bacteria to get close enough to take hold. Once they connect, different organisms use different tools to stay there. Gram-negative bacteria often reach out with pili or fimbriae, almost like grappling hooks, to pull themselves closer. Gram-positive bacteria rely more on surface proteins called adhesins that help them firmly latch on. After that, they start producing their protective matrix, the extracellular polymeric substances, or EPS, layer. And that's when a biofilm becomes incredibly resilient, resistant to sanitizers, and frustrating for any quality assurance team trying to troubleshoot. Now, here's a part of biofilm behavior that doesn't get talked about enough: the surface itself. Surfaces aren't neutral players in this story. They have personalities: hydrophobic, hydrophilic, smooth, textured, and bacteria absolutely have preferences. Hydrophilic materials like stainless steel or glass tend to attract gram-positive bacteria, especially when minerals are present. Hydrophobic materials like polytetrafluoroethylene, PTFE, and ethylene propylene diene monomer rubber are the favorite hangouts for gram-negative bacteria. Think Pseudomonas or E. coli, especially when even a thin layer of fat or protein residue is present. And those conditioning films, they change everything. A surface that should be low risk suddenly becomes highly attractive once a microscopic layer of organic matter settles in. It's like rolling out a welcome mat without realizing it. Even welds, scratches, gasket edges, and dead legs can create tiny hideouts where bacteria grab on and thrive. Once you start seeing surfaces the way bacteria do, hotspots become a lot easier to predict. So the natural next question is, how do facilities actually put all of this into action? This is where PBS really shines, because it takes microbiology and surface chemistry and transforms them into a practical, everyday monitoring strategy. It starts with simply matching organisms to the surfaces they prefer. If your environmental isolates are mostly gram-positive, your stainless steel zones deserve a closer look. If you're seeing gram-negative activity, gaskets, polymer components, and hydrophobic surfaces should move up your priority list. Then there's your process chemistry. Hardness ions, calcium, magnesium, tend to build up in low flow areas, and those pockets often become early attachment zones. When you know where those ions settle, you know exactly where to keep sampling. Residues matter too. Even when something looks clean, tiny films of fat, protein, or minerals can linger. Those films create new binding sites bacteria love. Thinking beyond clean looking to clean at the microscopic level changes how you target verification. Data becomes your guide. Trend your APCs, coliforms, spores. Look at patterns by surface type or equipment zone. Inline aseptic sampling can confirm whether your CIP cycles are hitting the mark between cleans. If a particular area keeps popping up, that's not noise, it's a message. And from there, you adjust sanitation. Not all materials respond the same way to a sanitizer. PTFE or rubber might need longer contact times or different chemistries than stainless steel. Tailoring your approach to the surface type makes your sanitation far more effective. When all of these pieces come together, PBS strengthens your HACCP and FSMA preventive controls and gives your process monitoring program a clear roadmap: where to look, when to test, and how to stay ahead of contamination instead of chasing it. At the end of the day, the goal is simple: fewer surprises, faster problem solving, and more consistent product quality. Proactive biofilm surveillance helps quality assurance teams operate with intention instead of reaction. It gives you the ability to anticipate instead of troubleshoot. And when you can predict where biofilms might form, you're better equipped to prevent them in the first place. That means fewer holds, fewer reworks, stronger food safety systems, and ultimately, greater confidence for everyone involved. If today's conversation sparked some ideas, or if you want to explore how proactive biofilm surveillance could work in your facility, check out our white papers, training resources, and sampling tools at qualitrue.com. Thanks for joining me on this episode of Safeguarding the Flow of Quality. Until next time, keep watching your surfaces, trust your data, and stay ahead of contamination.